What is an armor 1-1 model? Xt minus v1 xt minus 1 would equal to at minus eta 1 at minus 1. Agreed. One parameter for the AR side, one MA side, standard notation, we have negatives, some let's use positive there, positive there. You know, doesn't really matter. If I apply the backwards operator, I can write the first term, the terms on the left hand side as 1 minus v of b times xt. From that side, 1 minus eta 1 times b. Good. Our objective is to convert ARMA 1-1 to MA infinity. So I've got to move one of the side functions or v functions, v function, beta function, to the other side, right? Which term goes where? Should this go to the other side? Should that come to this side? We are trying to convert it to MA.
The xt side should go to the at side.
This has to go to that side. What is the next step?
There's a long division.
Long division, sure, but easy way.
Can you do a geometric series?
Geometric series, right? Sure, I could do long division, but why? I'll just do geometric series. Xt is equal to at times 1 minus beta 1b times 1 over 1 minus v1b, and that part is nothing but the infinite sum of a geometric series. So I could rewrite it as at times 1 minus beta 1b times 1 plus v1 plus v1b plus v1 squared b squared, v1 cubed b cubed, dot dot dot. I need 3 terms here because I'm trying to do something. 81 times that plus v1b plus v1 squared b squared, v1 cubed b cubed plus dot dot dot. Maybe we can even add 1 more term so you can see what I see. Distribute the second term, I'll have negative beta 1b, negative beta 1 times v1 b squared, negative beta 1 v1 squared b cubed, negative beta 1 v1 cubed b raised 4. Lastly, negative beta 1 v1 raised 4 b raised 5 dot dot dot.
Is that all? Is it 2 separate things we multiply by each other, no, it's one.
Yeah, once you multiply by all of this with the first part, last multiply by all of that.
All in the same parentheses.
Yeah,
Okay.
same parentheses. Good. Combine like terms, so xt would equal to 80 times 1 plus b1 minus theta1 b plus b1 squared minus theta1 b1 multiplied by b squared plus b1 cubed minus theta1 b1 squared times b cubed plus b1 raised 4 minus theta1 c1 cubed times b raised 4 plus dot dot dot. All I'm doing is combining those two, well, b out, those two, b squared out, those two, b cubed out, those two, b raised 4 out. That is good enough to get to a pattern of some sort. Okay. Downward to the base is to erase that part. We can change colour. So the next term or next step, 80. Let's swap it instead. B1 minus theta1 b plus b1 times b1 minus theta1 b squared plus b1 squared b1 minus theta1 b cubed plus b1 cubed b1 minus theta1 b raised 4 dot dot dot. My eyes picked up a pattern already. Does yours? So I rewrote that to get that term by pulling 80 out, but we always have 80 as a separate term in MA or even in our representation. So distributed, kept that 80, kept 80 out here, and the common term, V1 minus theta1 comes out, and this is what I have. There is a pattern. All I'm trying to do is write it in a concise or compact way using a summation sign. What should that summation sign look like? Or summation expression, I should say. Let's write that here.
So you start at I equals 0, then it would be like theta I b I plus 1.
Sure, I can start at I equals 0, but since that term's already there, let's start with I equals 1 to infinity. So b raised 1, b raised 2, b raised 3, not a problem. So I can write it as b raised I
theta just be I minus one, right?
So this part, I can write it as theta raised I minus one.
Or sorry.
Phi.
Feet, sorry, that's it.
Good. If I pull 80 out, now you may ask why. We'll see in a second. 1 plus Phi1 minus theta 1. So I equals 1 to infinity. Phi1 raised I minus 1. Phi raised I. Good. Now I actually know the transfer function for that MA infinity series. What is that transfer function? Big psi of B, where AT is the input, XT is the output. I would like to know what psi of B is, the transfer function. Omar, looks like you know the answer.
Everything in the square brackets.
Everything inside the square bracket. Good. That's what we want, the transfer function. Good. And you are going to say something nice, happen soon. Let's see. I'll erase that. I'll try to fit everything in here. That is original ARMA 1 series. I divided this, divided the equation by both by this term on both sides, expanded, did all the work, got that. That's good. Now I want to convert it to an AR infinity. So, same process, what should I do? Where should I start? Okay, then you know, looks like you know. So.
I feel like it's just XT instead of AT.
Okay, that is a guess. Just the XC.
I mean, and you have to flip the phi and theta.
Okay, then we've got to flip the phi and theta, and what else?
Well, and the phi, like when we, like inside the summation, that phi is a theta, but that theta isn't, it's not like the moving average where that theta is always the same, it's a different.
And we have to change the AT to XT.
So, having said that becomes XT, that would flip.
Yep.
Instead of flip, why don't we use the word change phi1 to theta1, theta1 to phi1, right? If I use that phrase, that becomes theta1, this would become phi1. I am changing phi1 to theta1, that should become theta1. That is the expression that I'm expecting to get. And we can easily get it by dividing both sides by 1 minus theta 1b And from here, the process is exactly the same. We are going to rewrite that denominator term using geometric series. So xt 1 minus b1b times 1 over 1 minus theta 1b is the infinite sum of geometric series. So I'll have 1 plus theta 1b plus theta 1 squared b squared, theta 1 cubed b cubed, plus dot 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 equals a sub t. Let's review. 1 plus theta 1b plus theta 1 squared b squared, theta 1 cubed b cubed, oops, plus dot dot dot. The other part, I'll just write it here, minus v1b minus v1 theta 1 b squared minus v1 theta 1 squared b cubed minus v1 theta 1 cubed b raised to 4 equals a t. Combine this with that theta 1 minus v1 b. Combine this with that theta 1 squared minus v1 theta 1 b squared. Combine this with that theta 1 cubed minus v1 theta squared b cubed. Manage it. I guess I can't. The xt I can distribute because we always want to have xt in our equation, just like we desire to have ac in there. So xt plus all the other terms. If you look at the expression, we will have theta 1 minus phi 1 as a common term in all, so I can pull that out. So, same logic, I equals 1 to infinity. This would be b raised I, b raised I, b raised I equals 1, 2, 3. And when you pull theta 1 minus phi 1 out, that expression would end up having theta 1. So 1 less. So theta 1, I minus 1, I equals 1 to infinity. AC. I'm missing the xt part here. If I pull the xt out, 1 plus theta 1 minus phi 1 from I equals 1 to infinity, theta 1, I minus 1, b raised I equals AC. Wish you had known this before that homework, right? I could have simply plugged it in the formula and got the answer. Things to know. That right there is also a form psi of b. Do we agree? If the input is xt, that would be the transfer function, like it, xt. In terms of notation, when we try to write it as an MA, the expression that we had uppercase theta or phi, correct? That's how we framed things. And over here, when we had an AR model, we used, do we remember? What was our notation? For the transfer function. So 80 is the output, x is the input, that is the transfer function. But we don't like to call it psi of b, this is actually psi inverse of b. But let's ignore that part. But for AR, we use the specific notation, the raise.
It's a capital B.
Capital phi of b. So if the input is xt, output is 80, then sure, this is psi of b. Agreed, input times psi of b is equal to output. But it would not make any sense in this case. Why would you take a bunch of regress components and try to come up with a random value? Does that make any sense? Would it be useful in practice? No. So rather, this is psi inverse of b, which is equivalent to saying uppercase b of b. Now do you see all the things that we wrote at the beginning, which is not making sense? Right, we're connecting everything together. Long time ago, you might have wondered, why should we worry about the transfer function, inverse transfer function, why the theta notation, why the uppercase b notation? It's the reason. Good. In electrical engineering, control systems, instead of b, they would use the letter z. There is a thing called a Z transform, but it does the exact same thing what we do in time series. If you took a Z transform and if you evaluate it at e raised negative j omega, which we are going to do, you know, that frequency part to get the spectrogram, you pretty much end up looking at this function in the frequency domain. Good. And you might wonder, well, what is the benefit of looking at it in the frequency domain? There was a question there, filter, right? These are simply filters. Technically speaking, a linear filter. You take an input, you pass it through a transfer function, you get an output. The moving average is going to behave in a way that it is going to keep all low frequency components, reject all high frequency components. So that would be a low pass filter. Autoregressive model, on the other hand, is going to get rid of the low frequency components and to give you the high frequency components, high pass filter. And then there's something called a band pass filter. We will not get into that. Good, that makes sense. That's signal processing, electrical engineering. I thought I would just make it complicated of my background. Oh, we can erase